says a 2,250 kilogram pickup truck has a velocity of 25 meters per second to the east. What is the momentum of the truck? So remember, what is the main formula that we're going to look for? Okay, the main formula. They're asking you to find the momentum, and the formula to find momentum is this one. Momentum is equal to mass times velocity. That means that all the data that you will get will be mass or velocity, and velocity, sorry. So we're going to focus on that. Now let's see. The problem is telling me that it's about a pickup truck, and this pickup truck has a mass of 2,250 kilograms. Okay, and it's also telling you that the pickup truck also has a velocity of 25 meters per second to the east. Remember, momentum has direction, so everything that involves direction must be included. Now, the mass given in the problem is 2,250 kilograms. The unit is already in kilograms, so I don't need to do conversion. Kilograms is the unit that I need, okay? Now, it also says that it has a velocity. It has a velocity of 25 meters per second to the east. So velocity is equal to 25 meters per second, and it is going to the east. And they're asking you what is the momentum. So to find momentum, all I need is this equation. So I need to see if the mass is given. Mass is given, yes. If the velocity is given, yes. So all you need to do is plug in the givens. So you say momentum is equal to the mass, which is 2,250 kilograms, multiplying the velocity, which is 25 meters over second. Remember that it's going to the east. You really don't need to write that it's going to the east, okay? But I write it just because I don't want to forget to include the direction. So, what is this? What is this?
I got 56,250.
56,250.
Yes, miss.
Okay. And remember, the units for momentum are going to be kilograms because of the mass and meters per second because of the velocity. So the unit will be kilogram times meters per second. And because it is a vector quantity, I need to write the direction. The direction is east. That's it. Just like that. That's simple. Unbelievable. This is probably one of the easiest topics because you only have to apply the formula. And yes, take advantage of this because it's a very easy topic. That's an easy 10 for a homework and an easy 10 for a quiz. So please take advantage of this. Just apply the formulas. Now, before I continue, remember that this formula requires velocity. And from what I saw the other day in the quiz, you already forgot how to do conversions for velocity. So in this moment, I will review conversions for velocity. Two very common conversions that you might need. One that is in kilometers per hour. Let's say that I give you a velocity of 80 kilometers per hour. Okay, so all you have to do is you have to write it in a fraction form. Remember, we need to express velocity in meters per second, so this is going to be the purpose, to convert from kilometers per hour to meters per second. So the first step will be to write the 80 kilometers an hour in a fraction like this, and then you will need the conversion factor. 1 between kilometers and meters. Since I have kilometers up, I will write kilometers down like this, and hours in the bottom, so I'm going to write hours in the top. So in 1 hour, I have 3,600 seconds. How much is this?
Is 22.22.
22.22 meters over second. Okay, so this is how you do the conversion. But sometimes, and that's one of my favorite conversions, is miles per hour. So let's say that we have a car, an object, that is traveling at a speed of 60 mph. mph is not meters per hour, it's not, it is miles per hour. Okay, so this is an abbreviation that we use. It is very common, mph. But we cannot do a conversion directly from mph, so we need to rewrite it as an expression. Miles per hour. Okay, how do we write miles per hour in a fraction way? So you have your number, which is 60, and miles per hour, that is miles in the top, per, which is the division, and hour, which is just h. So 60 mph is 60 miles over hour. And now you should be able to perform that conversion. So in here, I will use the conversion from miles to meters. In 1 mile, you have 1,609 meters. And then the conversion for hours. In 1 hour, you have 3,600 seconds. How much is this?
26.81 meters per second.
So remember, sometimes the velocities are not going to be meters per second and conversion will be required. Please don't forget how to perform this because sometimes you're going to use it. Now that was off topic, okay? That was off topic. But only this part is the momentum topic. Only this part. So as you can see, it is a very simple topic. But now we have another problem. It is about the world's most massive train. That one ran in South Africa in 1989. It measures over 7 kilometers long. The train traveled 861 kilometers in 22.67 hours. Imagine that that distance was traveled in a straight line to the north. If the train's average momentum was 7.32 times 10 to the 8th power kilometers meters per second north, what was its mass? So in this word problem, we need to focus on the question. The question is, what was its mass? So I need to find the mass. Remember, this is the main equation for momentum. And if I want to find the mass, then I have to isolate. My mass is going to be equal to the momentum divided by velocity. So what do I need for this problem? I need momentum and I need velocity. Now, momentum is given in the problem. It says if the train's average momentum was 7.32 times 10 to the 8th power kilometers meters per second north, that is the momentum, okay? So we're going to start writing the givens. The problem is giving me the momentum and it says that it's 7.32 times 10 to the 8th power kilometers meters over second. Now, let's focus on the extra givens. Here in the beginning, this sentence is not important. It's not telling you anything, okay? It's just telling you that it's about a train. And that was a train that is very massive. That means that the mass of the train is going to be big, really big. Okay? Now, what else I know about the train? It says that the train was over 7 kilometers long. Now, do I need to write this data? Do I really need to know the length of the train? Not really. This, which is the beginning of the problem, is not necessary to be this specific. Okay? Take a look. Everything about this is not going to help me. It's not going to help me to get what I need. I need momentum and I need velocity. Now you have to remember that velocity is a kinematic equation. We have a kinematic equation for velocity that says velocity equals distance over time. This one I gave it to you in the presentation. So in this problem, it's not giving you the velocity, but it's giving you the distance traveled and the time it took for the train to do it. Okay? So sometimes the velocity won't be given, but you can get it easily. Now, what do we do with 7 kilometers long? What's this data? This data is what we know as extra data, okay? We don't really need it because this has only one purpose. Description purpose, okay? It's just telling you that it was so massive that it had 7 kilometers long. 7 kilometers is a long distance for a train. So, but we don't need it. All I need to know is what distance the train traveled. And that distance is specified right here. The train traveled 861 kilometers. And the train did it in this amount of time, 22.67 hours. So the distance traveled is 861 kilometers. Remember, I don't need my units to be in kilometers, so I have to do a conversion from kilometers to meters. So I can do this in this first step. I can say that in 1 kilometer, I have 1000 meters. So this is equal to 861,000 meters. So the distance that the train traveled is already converted to meters. Now, the time it took for the train to do all that path was 22.67 hours. And again, I don't need hours. Remember, we need to express that time in seconds. So in this moment, we're going to convert from hours to seconds. So the conversion factor is, how many seconds do we have in 1 hour?
3,600.
So how much is this?
$81,612.
Thank you. So in this case, we already have the distance in meters and the time in seconds, and all I want to do is I need to find the mass. The mass of my train is unknown. So take a look. What do I need to get the mass? I need to know momentum and velocity. I know momentum, I don't know velocity, but I know that I can get velocity by applying this formula for kinematics. Velocity is equal to distance divided by the time. I have the distance and I have the time, so all I do is plugging in the givens. The distance, that is 861,000 meters, divided by the time, that was 81,612 seconds. My final units are going to be meters over second. How much is this?
10.55.
10.55. Okay, 10.55 meters per second. Now, in what direction was the train going? In what direction was the train going?
North.
North. So we write it too. Now that we have the velocity, we should be able to find the mass. So in this moment, I will find the mass by using this equation. This is going to be my step 2. Okay? In my step 2, from momentum, I isolate for the mass. I have the momentum, and now I have the velocity because I already got it. So all I need is, I just need to plug in the givens. So I say mass is equal to momentum. The momentum given in the problem is 7.32 times 10 to the 8th power kilograms meters over second north, and the velocity that I found in the step before, that is equal to 10.55 meters per second, also to the north. So this allows me to cancel meters per second with meters per second, and I don't need to write the direction because I just need to talk about how massive the train was. Now, what is the mass? If the answer is just too big, you can write it in scientific notation by pressing mode, okay? Then 2, that is for scientific notation, and then press 3. This will give you the answer in scientific notation. So how much is the mass?
Is 6.83.
6.94.
6.83.
Rounded is 94.
Now, this should give you the answer already rounded. Okay? And then times 10 to the 7th power. Okay? Don't forget